A buffer solution can maintain a relatively constant pH of solution. A buffer solution contains a certain amount of weak acid and a weak base. How does it work? If you add, say, a strong acid into the buffer, the proton from the acid will combine with the anion A minus to form weak acid HA. So the buffer turns strong acid to weak acid. Similarly, if you add a base into the buffer, OH minus is consumed by the weak acid in buffer. It's turned to weak base A minus. How to prepare a buffer solution? First, we have to know the relationship between pH value and a buffer, and the contents of the weak acid and its conjugated base, or the weak base and its conjugated acid. Let's check an acid ionization as an example. Ka equals the product of a proton and anion divided by Ha. We then take logarithm on both sides of the equation. We then have the equation written in logarithm. Since minus log x is denoted as px, then the equation is expressed in pH equals pKa plus log A minus over HA. This equation of pH is called Henderson-Hesbach equation. If we don't know the concentration of each species in the solution, the equation won't work. Now, consider that the ionization of HA is somewhat suppressed by A minus in the solution, common ion effect, right? We can assume that the concentration of the anion, the acid, at equilibrium is approximately equal to its initial concentration. Then we have the equation written in initial concentrations. Now we can use this equation directly to prepare a buffer solution.
Question: calculate the pH of the aqueous solution with 0.125 moles per liter acetic acid and 0.025 moles per liter sodium acetate. Let's see how can we do that. We can use HH equation directly to write pH equals pKa plus log acetate ion over acetic acid. Plug in the values, and we have the pH of 4.05. We can check the results without using HH equation. Using ICE tabular approach, we write initial 0.125 for acid, 0.025 for acetate. At the change, roll minus x plus x plus x at equilibrium, 0.125 minus x, 0.025 plus x, and x written as it be. We have the Ka equals reaction quotient equals 1.8 times 10 to minus 5. The result is 10.0 times 10 to minus 5, and pH is 4.04, almost the same value as that from HH equations. Question: calculate the pH when 0.015 moles per liter sodium hydroxide is added into the aqueous solution with 0.125 moles per liter acetic acid and 0.025 moles per liter sodium acetate. Sodium hydroxide is a strong base. reacts with acid and will consume exactly 0.015 molarity of acetic acid. The acid concentration changes 0.125 minus 0.015 to be 0.11 moles per liter. At the same time, the concentration of salt increases. The concentration is 0.025 plus 0.015, which comes from the neutralization of sodium hydroxide, 0.04 moles per liter. Now we use HH equation. We have pH equals pKa plus log 0.04 over 0.11. The pH is 4.3.